Good morning, dear students. Today we are going to do a practical to find out the acid value of a given sample of fat. So, what is acid value? I'm sure that you have learned about this acid value in your theory. Anyhow, let's see the definition. Acid value, it is the number of milligrams of KOH, that is potassium hydroxide, for what? To neutralize what? Free fatty acid that present in 1 gram of butter. So that's it. So by this experiment, we can understand the butter that we have is fresh or spoiled or rancid. Okay, then equation for finding the acid value is V into N into 56.1 divided by W. The V is how much KOH is used up in titration during this experiment, and N is the normality of KOH solution that we prepare. In this procedure, we are preparing 0.1 normal KOH. Then 56.1 is KOH molecular weight, and W is the weight of the butter that we used in this experiment in grams. So, what is the interpretation? As we get the result, get a value finally, based on that value, how can we interpret the quality of the butter? A low acid value. Low acid value means less than 0. It indicates the butter is fresh. So as the value goes up and as it crosses 1, it indicates that it is getting rancid. Means it start to become rancid, start to become spoiled. So high acid value indicates the hydrolytic rancidity due to the breakdown of triglyceride, because that butter is initially in the triglyceride form. Triglyceride, we know its structure, glycerol plus 3 fatty acid, that can be either saturated or unsaturated. Anyway, as it become rancid or spoiled, that fatty acid from triglyceride will get freed, and as the amount of free fatty acid become more and more, that much amount of KOH is required to neutralize that. So that is why a high acid value indicates the low quality of butter. So the acceptable limit also there. Acceptable limit means up to this much level we can consider that available butter for our consumption. Less, it should be less than 1. As it goes beyond that, as the value rises beyond this one, then need to consider its odor, its taste. It's not at all. It has started to become rancid. That's the interpretation that we need to understand from the value that we get out of this practical. So let's see what are the materials required. 5-gram butter, because for doing this practical we are weighing 5-gram butter. We need fresh as well as rancid, 5 gram each. 25 ml isopropyl alcohol, water bath, then beakers, burette, phenolphthalein indicator. So let's start the practical. First we are going to find out the acid value for fresh fat. So here I have taken 5 gram weighed fresh butter, and to this butter we have to add uh, 25 ml of isopropyl alcohol. So I have already measured 25 ml, and I'm going to add this one to the weighed amount, 5 gram of butter, fresh butter. Okay. So, and while this time we should not let any of the butter to stick on its side. And then we need to double boil it. Double boil it by keeping it inside another beaker, and then need to place it inside a water bath containing boiling water. Next, we are going to wait for a few minutes to get that butter completely melt. So now it's completely melt. We can see it so clear here. Okay. Then next, we are going to titrate it against 0.1 normal KOH. So for that, first we are rinsing a burette and filling that burette with 0.1 normal KOH. The KOH filled in burette is perfectly clamped, and next we are going to add phenolphthalein indicator solution to the melted butter. About 2 to 3 drops of phenolphthalein indicator we can add to this solution. Okay, then after that we need to swirl it. Swirl it. Okay. So we are going to titrate the melted butter, fresh butter against 0.1 normal KOH, and we should be very careful that we need to add only drop by drop because the result will not be a big number. So need to add drop by drop, and the end product is a slight persisting slight pink color. Okay, we are going almost going to get that the pink color. Oh, yes, it's this is the end point, slight pink color. Then we need to repeat the end same procedure for rancid fat. For this fresh fat, we got zero point 0.7 as the titration value. Acid value of rancid fat. For this also, I have weighed 5 gram of fat that was kept outside without refrigeration for 4 days. To this also, we are pouring 25 ml of isopropyl alcohol and need to double boil it by keeping inside another beaker, and after that placing it inside a water bath for a while. So to get it melt. So now it is completely melt. We can clearly see this. Then we are going to add phenolphthalein indicator 2 or 3 drops to it, and next to titrate it against 0.1 normal KOH, and we know the endpoint is the slight pink color. So we need to be very careful because when to add drop by drop only. So I think we are almost approaching the endpoint. So we need to slow down. Yes, almost attained. So, so yes, yes, this is the end point. And for the titration of the rancid fat, we got the titration value as 1.2. So this one. Next is the calculation. Calculation. First, we are going to find out the acid value for fresh fat. We know the equation. Acid value is equal to V into N into 56.1 divided by W. 56.1, we know it's the molecular weight of KOH. So we are substituting the value. What was the titration value for fresh fat we got? It was 0.7 into normality we know 0.1 into 56.1 divided by 5. The answer is 0.78. So that is the acid value for fresh fat. So then next we need to find out the acid value for rancid fat. For that again the same equation. We are substituting the value, and for the second time for the rancid fat we got the value as 1.2. 1.2 into 0.1 into 56.1 divided by 5. So for this, the answer is 1.34. So on looking to this, we can clearly understand that the rancid fat got highest value because it contains more free fatty acid. So as it contains more free fatty acid, that much KOH is required to neutralize that much fat. So that's why a high value. So this is the practical. I hope it's clear to you. Thank you.
I'm an icon, man. And my girl about a 10. I should fuck her in the Benz.